Hi Rahul.
Hi, sir.
So, what is this model you brought for presenting about
Uh,
its plan?
so this model is regarding the credit risk assessment. So especially is more designed for the loan default use cases, means uh, in financial domain.
It
So
means loan defaulters means nobody. Some people will not pay house loans. Example.
no,
Okay, then they are
uh,
the defaulters, right?
uh, they are defaulters with the help of their background history, like credit score, their employment, their living of standard. We predict if we give the loan to the next this particular customers, so he or she will be default on that particular loan or not. If he will be default, then we financial institution not give lend loan to that particular client. So that's why financial leading this lead to the significant means loan default. If we give the loan to the bad customers, so it can lead to significant loss to the bank. And in financial landscape, one of the biggest challenges faced by the banks are loan default cases. So to address this
Hold
challenge,
on, hold on, hold on. When you talk loan defaulters, they took the loan, they absconded, or they are not paying. That is called loan defaulters.
uh-huh.
Am I right, Ravi? The
Ye-
terminology.
Yes, sir, yes.
Okay, Abhi, your model, is it going to help during the process of the loan repayment defaulters or before evaluating the loan application, it is going to help? What way
before
it is
the
going to help?
before giving loan, it evaluate.
Then it is not loan default cases, it is going to evaluate the application eligibility, right?
Means that
Loan
is
application eligibility.
that we
Yes,
can
sir. So, but sir, first they means evaluate the document, and on that document they said he is a loan default.
on the basis of that, if he'll
In
be if
that,
he
yes, sir.
because in financial domain we can say the credit risk assessment. Means yes, we can say the credit risk assessment predict the loan
Then
default.
you need to mention in the second line like the loan application process, like that you have to mention it.
Yes, yes,
The approval process of loan application. In the
yes.
second line you mention it in third row
Okay.
now itself. No, no, no. In the below binary classification model you mentioned, na? Below that, the loan application process. Highlight it. You increase the font and color, something like that. Because during loan also we can identify risk assessment for defaulters. Okay, they lost the job, example, IT job. They'll give 3 months notice, they'll come and do the auction for the apartment or house or something like that. Am I right, Ravi?
Yes, sir. Yes, yes.
आप देखा था ना ऐसा केसेस आपके एक्सपीरियंस में बैंक में फाइनेंशियल
Yes, sir.
इंस्टीट्यूशंस में.
Yes, yes.
Okay, so now you can start explaining about these steps and tasks uh, in this model, Rahul.
So first task regarding the use case, define the problem. What is the problem? So this role involves, so in that particular case, business analyst or product manager come in picture. So it define the problem. So understanding the business needs and stakeholder. So in that particular loan default case, we will use to we want we will approve that particular loan or not. We have to find, and for that particular identify who will be used the model. Means this model will be used by the bank, NBFCs, fintechs companies to provide the loan to the particular client. So use case is that which help means credit risk assessment. We have to say, we can say. So this is a problem statement, first of all, and here role comes is business analyst and the product manager. And second one, after the identify the problems, so then we gather the data. So data data is fetched from the SQL server, or data we can get from the clients also. So here we prepare the data, uh, and the it data is prepared by the data engineer is there. So after preparing the data, uh, then we do the quality checks analysis in that particular data, is data with the help of Excel itself, if data is appropriate or not format. Initially, if we get any lacunas in that particular data, so we can inform client also, or we can ask for the new data, further moving to further moving. So after getting the data, then data, so data scientist roles comes, it import the data on the ID. So we can use Jupyter Notebook, PyCharm, or we can use the VS Code also for that importing data. After importing data, we have to import all necessary libraries. So pandas for the data frame structures, NumPy for the performing the all the arithmetic mathematical operation. So we have to import the NumPy also, and then we have to import the Seaborn library, Matplotlib library for the visualization. Then we have to import scikit-learn, that is a scikit-learn library for the uh, building, import the different model. So after the importing the library, we have to load the data with the help of the pandas function. Then initially we have to, after importing the data, then we have to see overview from the data. So what is our data? Is data is there we can use the info function, data frame info function, df.info. With the help of that info function, we can understand what is data type of particular features. So then we can check also if particular features are appropriate or not with the help of that particular. Sometime what happen, there is a integer value present in that all the column, but it appears as a object data type, so we have to correct all these things. So this initial process we do in that data processing and cleaning. In cleaning, when cleaning part is come, so initially we check the missing values, and then we can see outlier also. We can find if any miss something unknown number, or we can unknown symbol are coming inside the data set, then we check for that unknown symbol also. If sometime what happened in my data set, there a plus sign come in the instead of number, so we can have to check all the particular uh, data in correct manner. So after checking missing values, so we have to handle the missing values also, finding. So in my use case, uh, I have lots of amount of missing values, so I have to fill that missing value by the appropriate method, mathematical method like mode, mean, median, by with the help of the appropriate uh, seen the data, means if there is if particular value present in a more amount, so we can means frequently it appears, so we can see it is, we can fill with the mode. So then after data processing, then steps comes, that is the data visualization. So uh, some intuition of data we get from the mathematical operation like perform a describe function. With the help of the describe function, we get the all mathematical related stuff, that mean, max, high value, minimum value, maximum value, 25 percentile, 50 percentile, 75 percentile. So all the mathematical operation we perform here in the data here EDA process. Then when we come to data visualization, so here we can use Matplotlib and the Seaborn library to visualize the data. So in data process, the data visualization, what happen? We visualize the data with the help of the bar chart, scatter plot, with the help of the histogram. So we can analyze the data, means what is the data distribution. With the help of the data distribution, we can understand data is normal distributed or not, data is skewed or not. If data is data is not normal distributed, so with the help of the means transformation, we can come in, we can bring all the data into the normal distributed normally, because if data is distributed normally, it is helpful for the model to understand the data. So this data visualization we use to visualize the data. And and then after in my use case, generally I use histogram for the future loan amount and application applicant income. So with the help of that, we can analyze it, what maximum amount of people they are lying, which what amount, means which range of amount or salary. uh, so and maximum people, what amount of loan they take. So with the help of that, we can analyze our data set. With the help of this scatter plot also, we can analyze how one feature is related to other features. So how one feature affect the another feature. So if X increases, so Y increase or decrease, or they are distributed in a correct manner. So with the help of scatter plot also, we can analyze it. Then with the help of box plot, we can we can detect the outlier present or not. If there is an outlier present, if so we can remove the outlier. So with the help of with the help of the asking to the business analyst, we can take the advice of business analyst. We cannot directly remove. We have to take advice from the business analyst. Sometime what happen, these outlier are important for the client, so we can take that particular outlier as it is without removing. If it is a present, still we have to kept. So we can use the correlation matrix, because we have to see how one feature is correlated with other features. So we can use that heat map, or we can use Python's correlation function also. It can give the mathematical output how one feature is correlated with other feature. It show positive correlation or negative correlation, -1 to 1. That is a range for the correlation. So if one feature is positively correlated with another feature, so we can take that feature for building the model. And if one feature is not correlated with a target column, so we can exclude that feature with the help by taking the advice of business analyst or client. We can ask client also. If sometime what happen, client require that particular feature, so we have to keep. If it is not correlated with our target column, if then also after that correlation, after finding a correlation, so we can visualize the loan status count also. With the help of count plot, we can how much people getting loan, yes or not, so we can analyze. And with the help of that, we count, we can see the our data is means majority, or in the stakeholder, in majority state or minority state. Some what happened, in some time our data sets points are minority, so we have to take the care of that, so data is distributed correctly. Because if we train the data on the majority itself, majority point, so it can lead to the biasness while predicting the result. So we have to see that also. So in that particular use case, we use data visualization, and that data scientists play a important role to perform this particular task. Then feature engineering and selection. After performing that particular task, main step is feature selection and engineering. Means in that particular step, what happen, what we do means, lastly we do heat map, correlations. So here we what we do, we take the important features for model building, and some features are categorical features, so we can encode with the help of one hot encoding or label encoding. So according to our requirement, we encode the features and bring all the data in a numerical format. And sometime what happen, suppose there is a, in my case, loan id is not important in my use case, means while building the model, so I can remove or drop that particular loan id. So this, because here we perform feature selection, we take only important features and move on for the building the model. Then we save the data, and here also we perform the feature creation also. Sometime what happen, we combine two features and create another one features. So here in feature engineering, we create the features also and select the important features for the building the model. After feature selection, we go for the model training, because now our data in the numerical format for the in trainable parameter all there. And now next step is the model selection and model training. So here machine learning engineer and data scientists play important role. So for that purpose, we split the data into two sets: training sets and test set. And after this splitting the data, on the training set, we our train the our model, and after train the model. After training the model, uh, because this is a binary classification problem, so here I use for logistic regression and the random forest binary classification, catapult binary classification. But after training the model, we see the accuracy, if which model we gave the accuracy. In my case, I get good accuracy on the with the help of the random forest. And the then I because random forest is means helpful in the so sometime what happen, our data set contain large amount of outlier. So the random forest is a algorithm is automatically means handle the outlier, because tree depth net function present in the random forest. And then after training the model, I store the model on the with the help of that joblib library. Here is joblib library, means I dump the model. After the dumping the model, I load the model, and after in steps, I load the model, and with the help of the test data, I make the prediction on that particular load model. And this, because this is a binary classification problem, so to evaluate the model, I use precision, recall, accuracy, and F1 score. So we directly sometime what happen in our use case, loan default case, we cannot directly rely on accuracy, so we have to go for the precision and recall also, precision recall, true positive and false positive. Because in such case, loan default use case or medical use case, you can say we cannot directly rely on accuracy, because sometimes what happen, we when we give the loan to the defaulter, it lead to the loss to the bank. And sometimes we do not, when we not giving loan to the good customer, this is also lead to the loss. So we, in such case, we directly do not rely on the accuracy, so then we have to go for the precision, recall, or F1 score. So this is the evaluation matrix for the binary classification. Then after the evaluation performance, performing the evaluation, then model deployment integration. So with the help of the cloud, we can deploy, or no cloud environment like Streamlit or Flask, API Flask, we can deploy the our model. This here MLOps engineer or DevOps engineer play important roles to deploy when the model. Then after the model deployment, then it comes to the maintaining the monitoring the models. So model day by day, when new data come, day by day models redundance means accuracy decreases day by day when new data come. So we have to check the model performance also, and the we if we have to versioning the model. If model performance degraded, so we have to train the model, retrain the model when it is necessary. So that in here we CI/CD pipeline come to automate the model retraining. Then here is the ethics, regulation, and compliance. As the ethical implication of ML models, ensure compliance with data privacy and protection and regulation, and conduct bias and fairness assessment, monitor and mitigate the potential risks. So here ethics and regulation compliance. And then user interface for ML application. So here, lastly, we after deploying the model on the cloud, here we design the front end design. So here we can use the API plus also Streamlit library, which is present in the inbuilt library like pandas. Streamlit present in the Python. With the help of that, we can build the uh, user interface, menu-driven interface, and with the help of that, we can test our build model. So this is the overall um, roadmap, overall steps to be performed to perform this credit risk assessment use case. Okay, sir.
Okay, do you have the Python scripts also made it readily? Rahul,
Yes, sir. I have it.
do you have the Python scripts for each activity, for each step?
Yes, 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 yes. So this is
You're,
my
you're going to explain them today or in another call?
this. I will explain now itself.
Okay, okay.
So this is my data. So this is I import the pandas library here first of all.
No, 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 you need to share the screen. It is
Okay, 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 okay.
Excel is
Okay, sir.
there on the screen now. Share Python script screen.
It is visible now.
Yes.
So this is my Jupyter notebook. So initially I have to import the pandas library. So I import this first. Then here we can see wait, in the folder, home folder. Here you can see this is my Python script file. This is my train data. This is my test data, and this is my model. I store after training the model. Here I store the model. So now I show you the uh, my Python script. After loading the data, uh, the visible my screen, Ravi screen, my screen is visible.
No, no, no.
No, no. Okay, sir.
Yes,
Okay.
no, no.
Uh, now, now I show you the. This is my data actually. So there is a loan ID. There is gender, then married or not status, married status, dependency, how many people dependents on that this married person, education, that is graduate or not graduated, self-employed, yes or no, applicant income, co-applicant income, loan amount, then loan amount, loan amount terms, credit history, and then here comes uh, uh, property area, urban or rural, and there is a loan status. So this is all about the my this table, loan default table. So now step by step I explain you. So here I perform the head function. So with the help of the head function, we can see the first five numbers, five rows, and then uh, with the help of df.tel, we see the last 10 rows. So now I have to see the shape of my data set. So here you can see I have 13 column, and and there is a 614 that is a rows. So with the help of now I want to get the information related to what the features, data types, how many null value present there, and so with the help of df info I get the information like loan ID. In loan ID, there are 614 non-null value here. Here we can see there is a 641 entries and 641 entry non-null value. In gender, there is 601 non-null values. Married also, we can see dependency also 599 non-null values, and self-employees 582 non-null values, and application also 614 non-null values. So here we can see the non-null values, and here data type, float data types, in data types, and object data types is here. After then we check the null values. We check the null values with the help of df.isNull.sum. So here you can get the in gender column there is 13 null values, self-employed 32, dependency 15, and loan amount term 14, and loan amount 23, and credit history 50. So we have to do some operation on to remove that null value, or we have to fill that null value. With the help of use business use case, we have to perform the operation. So now next step, there is a loan ID not required while building the model, so I drop it. So df.drop loan ID, so I drop. Then you can see the my new data sets or the data frame. After that, what you can see here, gender, um, then dependence, loan amount, and the loan amount, and the we can see the loan amount terms. Here are some null values present here in that particular columns. So with the help of drop NA, drop null value, I drop the null values. So here we can see after dropping, I here only credit history. There is a null values present. Otherwise, all the features are equal, means now equally distributed 553, 553, 553, 553. Only credit history there is a 550, null value. So I have to do operation. So I use mode function. Mode function means most frequent occurring values. So in that credit self-employment, there is a no and yes value is there. So with the by using mode function, there I get no. So this no is the most frequently occur. So in self-employ, I input this fill NA, where is a NA null value is present. With the help of that, I fill that null value with the mode, a mathematical operation, that is a no. So after performing this, I get the when I perform df.info, then I get the self-employed column is filled with the 553 with all the values fully filled. Now here we can see only credit history is not correctly matched with our above uh, rows. So I have to do some operation on this. So again I do mode. So the credit history df credit history dot mode. So I get one. So now I, with the help of one, I fill the null value. So I use df create history dot fill na, fill the null value with the mode 0. Here I use mode 0, and then I fill the all the value. Now handling the categorical column. Here you can see gender, education, then property area. These are the all the categorical columns. So I have to do some uh, matter means I have to convert this categorical feature into numerical feature. So now again I have performed df.info. So here you can see the all the rows are in the same manner, means equally distributed, means equal numbers. No. So now you can see in dependency, here you can see in starting dependency, there is a 3 plus number is there, 3 plus. So this is not valid because our machine learning machine only know the numerical value. Plus is not a numerical value. So we have to do some operation on that particular value. So I perform replace option. So in Python there is a replace in dependency df dependency replace 3 plus value with 4. So after the performing this, I replace the my null value, oh sorry, 3 plus value with 4. And then when I perform the unique operation on that dependence features, so I get unique value 1, 0, 2, 4, only this. And then I see the loan status. unique. So there is only two column, yes or no, in loan status, unique value, loan, yes or no. So now here you can see there is gender, object data type, married object. So here on this object and flow data type. So dependency, income application, then loan amount. Some features are object data type. So we have to convert into integer, integer data type because they are all integer, not a object or object data type. So with the help of as type is which help in a conversion of data types. It is help in model building when we convert our data features into appropriate data type format. So it helps. So I convert the data means data types. So gender, I convert gender map. I map gender is equal to male is equal to 1, female is equal to 0 because I have to convert that categorical feature into numerical features. So that's why I assign male to number 1, female 0, and convert data type into a int. Same manner, married also. I map married yes is equal to 1, no is equal to 0, and convert into int data type. Graduation 1, non-graduate 0, and convert to int. And same manner, self-employed yes is equal to 1, no is equal to 0 as type or as data type is int. And property area also, rural 0 and semi-urban 2 and urban 1, I assign this value and convert this into integer because I have to assign some data type to it. And loan status also, there is a two unique feature, yes or no, and I assign this value 1 and 0 and convert it into int. So after this execution of this cell, I get all this data because now all my data get converted into numerical and integer data type. So now this data is readable format, machine readable format. But before going to do, we can see the applicant, co-applicant number, loan amount, and terminology. These three features. So here you can see the co-applicant number 1508, then 0, then 2358, then 0, then 4896, then so these numbers are far away from each other. So they are not normally distributed. So I have to perform some transformation operation, transformation logarithm transformation, or we can say the standard scalar or min max scalar to bring all these data in the particular range -1 to 1, or standard scalar we can say through -3 to 3. So if I bring all the data in the that particular range, so it is help data is normally distributed also, and it helps model to learn very well and give the accurate good accuracy. So that for that purpose I perform scaling operation on that my particular entire data set, not entire data set, but this loan applicant number, co-applicant income, loan amount, and loan amount term, because these data are distributed widely from each other. So I import the from scikit-learn dot pre-processing import standard scalar. Then I create the object of standard scalar, and here is a in column there's a list. I in that vertical variable, I store that all the variable, and then I perform the transfer operation on that these four features. After performing this transformation operation, here you can see the all my data are now income in one particular range -3 to 3. Now it is help in building the model and reduce the error while building the model. So because I made the all my data in particular range, so it is a help in pattern, and it help in model to understand the pattern very well. Now perform after performing the scalar operation scaling, now it's time to split the data. Then here I split the data with the help of the trend test split scikit-learn, and here I perform the what one one I here I write the one function. In that function I write the all the code related to trend test split, then fit. Because why I write this? Because I have to perform train the model on uh, two or more than two or three algorithms. So every time writing the code, it is not good practice. So I call this function while executing the every time one algorithms for code redundancy, avoid a repetition of code. So here we can see the it print the accuracy. Then here is a cross validation score also is print, and after round it off. So now first there I call this model val. Here is you can see model val. This is a function. I call this function by importing the logistic regression. And when I call this function, execute this cell, and I give the accuracy, means logistic regression accuracy 0.80%, logistic regression accuracy with the cross validation score 0.84%. Now again I call the decision tree classifier. Then again I call this function, and then also I get the this accuracy 72% accuracy on, and then decision tree classifier with average cross validation 74. Then I again call random forest function, random forest, and I call the above function, and same accuracy and cross validation accuracy. Then I gradient boosting also I use, and then support vector machine classifier. So here you can see the accuracy, but now I want to perform the want to increase the accuracy, and I have to reduce the this training and test data's difference. For that purpose, I use hyperparameter tuning. So I here perform hyperparameter tuning from scikit-learn model selection import randomized search. Here I not using grid search. Here I use randomized search for to tune the hyperparameter. So here I use logistic regression model to use logistic regression, and use log space minus 4 to 420, and solver is linear, and here I use hyperparameter, and with the help of the hyperparameter I got 80% accuracy. Then support vector machine I use kernel as a linear, not polynomial. Here I use linear kernel, and with the help of that this hyperparameter, I train the model with, and I get the accuracy as 80%. And then same, I do random forest. Here I use maximum feature as R2 and square, maximum depth also I 30 till 30, and minimum split 200, and maximum split. So these are the 10. These are the all the parameter I use to train the model, and then I got the accuracy 80%. So we can see the with the help of random forest, I get good accuracy 80.66 as compared to here above. Um, Random forest is here without hyperparameter tuning, I get only 77% accuracy, but with the help of the hyperparameter tuning, I get the good accuracy as 80% on the random forest. So I save this random forest model. So here you can see this is a loan status predict. This is my save model. With the help of job leap, I save the model. Now for the prediction purpose, I create one data frame. Here I give the I give the values, and I create the one data frame, and then I pass this data frame to my model. Here is my model in that particular model variable. After passing, if result is equal to 1, print loan approved, else loan is not approved. When I pass this data frame to the model, it show that loan is not approved. So, and this is my output, loan is not approved. And so this is my Python script. So, and this is also one of the, I create one GUI, user interface also for the prediction purpose. So, sir, this is my all over task from the prediction till the prediction.
Okay, it is a very good data analysis also you have done through data flow from stage by stage, step by step. It is very good. Okay, let me stop the recording for this one.